Hi, my name is Niddal, a PhD student at University of York. The title of my paper is A Survey of Attacks Against Twitter Spam Detectors in an Adversarial Environment. My presentation is divided into 4 sections. First, I will give a brief introduction about the topic, then I will talk about the proposed taxonomy of attacks against Twitter spam detectors, then I will discuss some potential defense strategies, and finally is the conclusion. Several studies shows that the number of users and the amount of information being shared in online social networks such as Twitter, Facebook, and others are increasing every year, and unfortunately the high popularity of these platforms has made them very attractive to spammers. Spam is referred to unwanted messages that received from unknown users. Spam may contain malware, or advertisement, or malicious URL. Although spam can be found in all forms of online communication such as email and the web, researchers' attentions has increasingly shifted to spam in online social networks due to the variety of spam that can be found in online social networks and the possible negative effects on users' experience. Many solutions have been proposed to detect spam in Twitter by using different techniques such as blacklisting, whitelisting, and recently machine learning techniques. However, machine learning techniques have become or have been shown to be very effective when deployed to solve security issues in different domains. In machine learning, the aim is to automatically classify tweet as either spam or non-spam. Actually, there are different types of Twitter spam detectors. There are Twitter spam detectors that use account-based features such as number of followers or number of friends. Also, there are Twitter spam detectors that use tweet content-based features such as number of words, number of characters, or even number of URLs or hashtags in a tweet. Also, there are Twitter spam detectors that use relation-based features such as connectivity. This is a general learning process that we use when we train machine learning-based spam detection. And as you can see, we have 3 steps: data collection, pre-processing, and classification. In pre-processing, first we have feature extraction, dataset labeling, dataset splitting, and then in classification we have training data to train the machine learning algorithm and testing data to evaluate the accuracy of the machine learning algorithm. The success of machine learning models in detecting spam has driven adversaries to attack the model itself to undermine its performance. Recent works reported that machine learning models have become the weakest links in the security system. Adversaries can send adversarial examples to cause misclassification, and as you can see here, the adversary can access the model using the same channel as the legitimate users to gain some knowledge about the deployed classifier, and this makes adversarial attacks are hard to be defended against in Twitter. Attacks against machine learning models can be categorized along these 3 axes: the attack influence, the kind of security violation, and the attack specificity. The attack influence could be either causative, if the attack influences the training data to cause misclassification, or exploratory, if the attack exploits knowledge about the deployed classifier to cause misclassification without any direct influence over the training data. The kind of security violation have integrity violation if an adversary evades detection without compromising normal system operation. Availability violation, if the adversary compromises the normal system functionalities available to legitimate users. Or privacy violation, if the adversary obtains private information about the system. The attack specificity could be either targeted if the attack focuses on a particular instance, or indiscriminate if the attack focuses on a wide class of instances. This diagram showing how the adversary can attack Twitter spam detectors at different stages. The adversary can attack the model on training phase. The adversary can inject adversarial examples into the training data to cause misclassification, and this is called causative attack. Also, the adversary can attack the model before the prediction or the inference time, and this is called exploratory attacks. Actually, defending against causative attack is challenging because the model needs to be retrained repeatedly, and in order to retrain the model, we need to collect data from an adversarial environment, which opens up an attack surface. Also, defending against exploratory attack is difficult because, as I showed earlier, that the adversary can access the model using the same channel as the legitimate users. So defending against these kind of attacks by using traditional encryption or traditional security techniques is not applicable. Now we'll talk about the proposed taxonomy of attacks. Different hypothetical attack scenarios were proposed by using the following steps. First, I categorized attacks based on the attack influence and the attack or the security violation. Second, I identified the attack settings, which includes an adversary's goal, knowledge, and capability. Finally, I defined the attack strategy. Examples of tweets that could be used in such attacks were extracted from Arabic trending hashtags because there are active campaigns spreading untrustworthy products. Was found in Arabic trending hashtags. The first attack category is causative integrity attack. Two different attack scenarios are going to be discussed under this category. First, we have a poisoning attack where an adversary attempts to contaminate training data to cause misclassification. Here, first, the adversary would carefully craft a large number of what I called adversarial spam tweet, which contains spam and non-spam components. Then the adversary would post those adversarial spam tweets using trending hashtags and hope that the defender, or in our case, Twitter, will use those adversarial spam tweets when retraining the model, and this will cause misclassification. This is an example of a spam tweet that could be used in such attacks. This spam tweet has spam and non-spam features, and the goal is just to contaminate the training data. And the second attack scenario under this category is red herring attack, and the aim here is to mislead Twitter into using fake features by influencing the training data. Here the adversary would carefully craft spam tweets that has a fake feature. As you can see here in the spam tweet in the left side, the adversary used a fake feature, which is a telephone number, to mislead Twitter into using this fake feature when classifying tweets. So in the future, the adversary would avoid using this fake feature to bypass the detection. And as you can see in the second tweet, the adversary inserted the telephone number inside an image to avoid detection. The second attack category is causative availability attack. Here the adversary's goal is to either corrupt the entire classification process or to make future attacks easier. The attack needs to contaminate a large portion of training data in order for these attacks to be successful. So using crowdsourcing sites or spam bots could help with such attacks. This is an example of showing the effect of causative availability attacks on Twitter. These two spam tweets remain undetected for over 50 minutes, which is a very long time. The third attack category is exploratory integrity attack. Two different attack scenarios are going to be discussed under this category. First, we have probing attack, where an adversary aim is to learn or expose some of the deployed classifiers functionalities without any direct influence over the training data. This is an example of spam tweets that can be used in such attacks. These spam tweets advertise the same products. However, as you can see, each spam tweet has different features. The first one has text, URL, and an image. The second one has text and an image, and the last one has text only. So the goal here is just to learn the feature used by Twitter. So for example, if the first tweet detected by Twitter, then the adversary would know that Twitter used the blacklist of URLs. The second attack scenario under this category is evasion attack. Here, as you can see, this spam tweet. In this spam tweet, the adversary inserted the spam words inside an image to evade detection. And the last attack category is exploratory availability attack. The main aim here is to evade detection by overwhelming the model without any direct influence over the training data. Here the adversary would flood the system with adversarial spam tweets that required more time to be processed. And as you can see, this is an example of spam tweets that could be used in such attacks. These spam tweets contains only an image, which need more time to be processed. So this kind of spam could be used to launch denial of service attacks. In order to develop an adversarial spam detector, adversarial aware spam detector, the following points need to be taken into consideration: protecting security and privacy of machine learning spam detectors. There are two strategies that commonly used in the literature. We have disinformation and randomization. Also, developing a fully automated model that can filter adversarial spam tweets is important. Also, selecting features that reposit to adversarial activities is important, and some of the recent works suggested using time-based features, because these kind of features are difficult to be mimicked or altered. In conclusion, the goal of this paper has been to provide a comprehensive overview of different possible attacks against Twitter spam detectors, which is the first step towards evaluating the security of spam detectors. And the main contribution of the paper are a general taxonomy of attacks, of potential adversarial attacks against Twitter spam detectors. Examples of adversarial spam tweets were presented. Also, possible defense strategies were discussed. A number of challenging issues that future research need to focus on were mentioned. For example, detecting image-based spam, also spam campaign detectors may fail to detect single spam and vice versa. Also, current defense strategies cannot completely prevent attacks. In terms of future direction, after identifying potential attacks against Twitter spam detectors, the next step is to simulate some of these attacks to help developing more adversarial aware model in the future. Thank you.